Getting the combined DMX from the console and zactrack to the fixtures can be a confusing task. There are network protocols, Ethernet cables, 5-pin, nodes, and switches to think about. In this video, we hope to simplify the concept of merging the data, outline the various methods to accomplish this task, and demystify the terms we use along the way. It is time to get started. The first two methods we will look at involve two well-known network DMX protocols, sACN and ARTNet. One or both of them may already be used in your show. I first want to review the overall zactrack network. The center of the network is the zactrack server. It is the brain of the system which receives the DMX data coming from the console, calculates adjustments based on the location of the trackers, and then outputs the result to the fixtures. The zactrack server sends zacnet out of its yellow port to the anchors via a PoE network switch. This is its own network, which in no way overlaps with the DMX data going to the fixtures. For the purposes of this video and DMX merging, we don't have to worry about the zacnet network. Once the calibration is done, the server continues communicating with the anchors and trackers and requires no further configuration. On the network DMX side of things, regardless of whether you use sACN or ARTNet, everything is all connected through a network switch at the center. This should be a separate network switch from the one used for zacnet. A unmanaged network switch is going to be the simplest way to go. However, if you do choose to use a managed switch, make sure to check all the various settings needed to let the DMX data flow to all the hardware. The three pieces of hardware and communication on this network are the ZAC server, the console, and the DMX node or gateway. The zactrack server is connected via the red Ethernet port, because this is the port dedicated for DMX data. On the server screen is an IP address labeled light. This is the IP address for the red port. The other two devices, the console and node, will need their Ethernet ports in the same IP address range as the ZAC server. What Ethernet port on the console the cable needs to be plugged into will depend on the manufacturer of the rest of your hardware. Please consult the manufacturer's manual for this information. The last piece of the network puzzle are the fixtures. They will be plugged into the node using typical 5-pin DMX cables. Let me take a minute to explain why this step can be a little complicated. The ZAC server does not have any DMX ports on it. So, to communicate with the fixtures, it has to send a network DMX protocol. If we are using the zactrack system in combination with a lighting console, then the console will also communicate with the server using a network protocol. But since the console, server, and node are all on the same network, how does the node whether to listen to the information coming from the console or the zactrack server? Luckily, zactrack passes the entire universe from input to output and only modifies the specific attributes needed. So you really only need the node to listen to what's coming from zactrack. With sACN, this is simple because sACN has priorities, so you can give the server a higher priority than the console. ARTNet, however, does not have priorities, so instead you offset the universes in such a way that the node will listen to the universes from zactrack and ignore the console. But what if you don't have a node and are just using the DMX ports on your console to control the fixtures? If your console can receive sACN or ARTNet and merge it back into the output, you can actually take back the signal coming from the server and output it. However, you will again need to offset the universes so that you don't create a loop within the same universe. Note, not all console manufacturers can merge received sACN or ARTNet into the regular DMX output, in which case you will have to use a node or gateway to integrate it in the zactrack system. Now, with a basic understanding of the overall network, along with an overview of what we're trying to achieve, let's look at how to use sACN in the setup. A quick note on console settings. We will be demonstrating how this works using GrandMA3 software. All terms we will use like universe, multicast, input, priority, etc. will carry over to other console manufacturers. But the details of the process may look different on your particular console. As we just mentioned, when working with sACN, we are outputting our fixture universes from the console to zactrack. and then outputting those same universes from zactrack with a higher priority. This way, when the sACN data from both places reaches the node, it will listen to the higher priority zactrack signal. We are here in the grandMA3 sACN menu. The first setting we need to check is which Ethernet port is being used, and its IP address. In grandMA3, we can use any port for sACN. I have also set the console's IP address for port 1 to be in the same range as the red port on my ZAC server. This is the first place to start when getting everyone communicating. The next thing to look out for is to make sure output is enabled in general. In grandMA3, we just need Enable Output turned on. Now, we can configure our specific sACN data lines as follows. Make sure the individual data line is enabled. Mode should be Output Multicast. You can also use unicast if necessary, but 9 times out of 10, multicast will suffice. Next, we need to know what universes our fixtures are patched into, and make sure those universes will output via sACN. In this example, they are all patched into Universe 1, in both the console and zactrack. So, for grandMA3 sACN settings, we will set the local universe to 1, and the sACN universe also to 1. And because we only have one universe of fixtures we're controlling at the moment, the amount also gets set to 1. The priority is the last setting to check here. sACN priority can go anywhere between 1 and 200. The default for grandMA3 is right in the middle at 100. We are going to leave this at 100 and set zactrack's output to 1 higher. These are all the settings we need to output Universe 1. We also need to make sure we are outputting the universe we're using for the zactrack control. In our example, Universe 10. I'm going to add a new line, make sure it's enabled, set the local and sACN universe to 10, leave the amount at 1, and the priority at 100. The console sACN network setup is complete. Now we jump over to zactrack. We already began the universe setup in zactrack in earlier videos. We just need to finish some key components. In the Universes tab of the Show Editor, click on the Out1 universe to edit it. This is the only universe in need of adjustments. The priority defaults to 100, but we need it to be higher than the console, so we could change the priority here to 101. The other setting is the In Merge, which tells zactrack how to route the incoming DMX back out. In this case, we need zactrack to merge the data that is coming in on Universe 1 to go back out the same way. So set the In Merge to In 1. Then we could press OK. Open up the cache of In 1. If we change values on the console, we could see them reflected here in the cache. Close out of this menu and open the cache for Out 1. If we continue to change values on the console, we also see them reflected here because they are merging through zactrack. However, we will see different pan and tilt data here based on the tracking information being sent to the fixture. We have all our fixtures currently following tracker 1, and we could see all the pan and tilt data changing. Before we leave the topic of sACN, keep in mind we are not sending sACN back into the console. It's only being output from the console, with zactrack and the node handling everything from there. Now, let's see how this would change if we were using ArtNet. Among many differences between sACN and ArtNet, perhaps the most relevant in this situation is that ArtNet does not support priorities. This means we need to approach the setup a little differently, because if we send the same universe onto the network from the console and zactrack, the node will not know who to listen to. So we start by sending Universe 1 out of the console into zactrack, just like before. However, this time we're going to send a different universe back out of zactrack to the node. On the console side of things, I'm sitting in the ArtNet menu within grandMA3. Again, the locations and names of these settings may be slightly different depending on the console you are using. I am still working in the same IP range, but now sending ArtNet instead. Note that some older devices may only be able to use ArtNet with an IP range that uses a 2 or 10 for the first octet. Something to check if you're thinking of using ArtNet. Output is enabled once again. I have my 2 ArtNet data lines with slightly different configurations. My local universe for both is still 1 and 10 because this is where my fixtures are patched in the console. The amount for both is also 1 because we are still only sending one universe for each line. For the line sending universe 1, I set my ArtNet absolute column to 0, which automatically sets the net, subnet, and universe to 0. This will be the first ArtNet universe, because ArtNet starts counting from 0. For the line sending universe 10, I set the ArtNet absolute column to 9, which automatically sets the net and subnet to 0, and the universe to 9. On the zactrack side of things, we're going to start from the sACN settings we already have in the Universe tab. Click on In 1. First, we need to change the protocol to ArtNet. Then, we need to set the universe to 0 because zactrack also has the option to think of ArtNet universes in absolute. This will keep it in line with what the console is sending. Press OK when complete. Then we need to click on In 10. Change the protocol to ArtNet and set the universe absolute to 9. Lastly, we need to click on Out 1. When we change the protocol to ArtNet, we only have one sending option, which is unicast. Unicast will send the ArtNet to the node and only the node. However, we will need the IP address of the node to make this happen. Next to unicast targets, tap the green plus and type in the IP address of the ArtNet node. Then press OK. Now we need to set the sending universe to an open universe, not 0 or 9. I will choose 1. The In Merge setting will stay in 0, which is what we want. Press OK when complete. The last piece of the puzzle for ArtNet is to check the node. It needs to be set to receive the ArtNet universe being sent from zactrack. In this case, ArtNet universe 1, not 0. Keep in mind, in this configuration, because we are merging through zactrack and the node is listening for the universe zactrack is sending, the server must be powered on to control your fixtures. Your console cannot control the fixtures otherwise. What if you don't have a node and need to send 5-pin DMX out the back of the console? How can zactrack fit into that scenario? This method is similar to the ArtNet method, except that instead of having a separate node, you use the console as a node. You send the universe out of the console into zactrack, and then zactrack sends the different universe back into the console. The physical DMX ports on the console are then set to output the universes coming back from the zactrack. For this method to work, your console must be able to receive either ArtNet or sACN and merge the input into your console's output. Not all consoles can do this. Check with the console's manufacturer before using this method. If your console cannot do this, you will have to get a node or gateway and use either the sACN or ArtNet method outlined earlier. With GrandMA 3, we can use either ArtNet or sACN for this method. In this example, we will use ArtNet because we already have the settings mostly in place. We are outputting local universes 1 and 10 because this is where the fixtures are patched. In zactrack, we will also use the same settings with in universes 0 and 9. However, we need to change where Out 1 is sending the data. Instead of unicasting to the node, we need to unicast back to the console. Remove the unicast target we have and add a new one with the console's IP address. I'll also adjust the description to zactrack to console. Perfect. Press OK when complete. Back in the console, we need to make sure our ArtNet configuration is set up to receive input. First, toggle Enable Input on. Then we can add another ArtNet data line. Enabled Yes. Mode is input this time. Local universe will be an empty, unused universe. In this case, 2. Amount is 1 because it's only a single universe. And ArtNet Absolute is 1 because that's what is coming from the zactrack server. Now all that is left is to make sure the DMX port our fixtures are plugged into on the console is set for universe 2. For GrandMA 3, we find this in output configuration. The fixtures are plugged into port A, so we will change it to send universe 2. Looking at the DMX sheet on our console, for universe 1, we could see our fixtures are patched as we change the data it changes on the sheet. Now, scroll down to universe 2. There is nothing patched here, but we could see the values moving in the DMX sheet. Plus, the lights are changing on stage. This is because our DMX is going out of the console into zactrack. It is taking on the new position data from zactrack, and then is sent back into the console on Universe 2 and out to the lights. Just like the ArtNet method we looked at, we are merging through zactrack, and the console is listening for the universe zactrack is sending to control the fixtures. Your console cannot control the fixtures without the server powered on in this type of configuration. Phew, was that all? Now with an understanding of all things DMX Merge and zactrack, which method works best for you? Are you using a node? Does your node accept sACN? Can your console send and receive ArtNet or sACN? These are all questions to ask yourself when considering how to integrate zactrack with your lighting system.